you're sick or you want to go over something again that we went over, you can pull it up from the weekly podcast in Eagle. First thing we want to make sure we do is everybody make sure on your computers. I had everybody logged in, but that's the login when you come in. Everybody's one credential login. And let's make sure everybody can get into Eagle on these machines. That would be great if you're not already logged into Eagle to make sure you can see the course. We're going to go over that tonight. We're going to do intro to chapter 1. Go over the makeup and content of the course. And then what we were going to do this week for lab, we're going to do next week just because we weren't here last week. But the makeup of the class is when you first come in after you check in, you will I'll go over any announcements we have for that night. And then we'll go right into the content of that week discussion. We'll take a little break usually and then do a lab. Most of your labs will be working with the people around you. There'll be some individual labs. Like next week, our first lab that was slated for tonight, we'll do it next week, is a group lab with 3 or 4 people in the group where you'll draw up a diagram of the makeup of how computer networks can be laid out. So let me make sure I've got everything running here real quick before we get started. Copy that. And so as you see on the overhead, I'm going to take the go into module 2 for week 2. And the one that was in there from last time, last semester, I'm going to replace that podcast with this one. And all it is basically is a podcast is just a screen recording of what you're seeing and hearing in the room. That's all it is. Okay. First thing we're going to do is a Kahoot. I like to do in all of my classes. Kahoot is a game that you can do quizzes, you can do polls, you can do surveys, and I like to use it just kind of an icebreaker to get things started each week, going over the content of what we've covered. Since this is the first week, we'll do the intro to the pct110. You will need your phone for this, and what you'll do is once it starts up here, there'll be you'll go to the website kahoot.it. It'll show you right there. Go to kahoot.it from your phone. Put in that pin. Think of a creative name. Doesn't have to be your real name. It could be a fictitious character that you've always wanted to be, or some supervillain or super person. There we go. We got 12 players we should have. So when we reach 12, I'll start it. You can play this on your computer as well, but if you have your smartphone, you can play it on that as well. All right, 2 more. Waiting on 2 more. Is that right? 1 more. Waiting on 1 more. Well, now we have 1 drop out. Well, they're back. Okay, 1 more. We'll wait just a second longer, and then we're going to go and start it. Okay, I'm gonna go ahead and start. Here we go. 9 questions. Have you ever set up a network LAN local area or for a small business? Yes or no? Well, let's see here. Majority no, 2 yes. And this is an intro to networking class. That's a perfect answer for this type of course. So you have no knowledge whatsoever of networking coming in to the course. Have you ever set up a LAN, a local area network for your home, like a Wi-Fi network possibly, or for work? So most of you have set up a Wi-Fi at home. That's great. Next, what does LAN stand for? And again, this is not for grades, so whatever you think it might be, local animated node, latency annotated node, or local area network. Just a pure guess here. Supposed to be doing some reading, but most of you, local area network, that is correct. What do you think a peer-to-peer network is? Client-server net connection or a client-client connection? It is a client-client connection. What do you think a LAN network is? Client-server, client-client. Client-server is the answer on that. Are you interested in internship opportunities this semester? Of any IT type, yes or no, or maybe? All right, so we have some maybes and half on the yes, no. Great. And while we're on this page, we do have a website, myrvc.org, which is our division site. So right up here, be a good idea to bookmark that on your phone. We have on this site job postings, full and part-time. The companies will work with you as a student. We also have internships. Also events that are coming up this semester. Also, you can connect to our advisor here on campus online in our division, Stephanie Walsher. Just to name a few. And from that site, you can also follow us on Facebook and Twitter, because anytime we post any job listing or announcement, it'll come directly to your feed for connection. So why are you taking this class? Go ahead and tell us why here. Graduation requirement, general knowledge, work requires it, or other. All right, so majority would be graduation requirement and then general knowledge, everybody else. What interests you about networking? If there was something that interests you, we could learn to combat hackers, learn how to secure network, better prepare if a network issue happens at work. Making the big bucks, or the bug bucks as it says here, $20.15 an hour or $51,855 a year. By the way, the movie there, Angelina Jolie, and the gentleman plays Mentalist, can't remember his name, from the movie Hackers. You didn't see that, was a good one. There we go. So let's see, roughly 50-50 on the being prepared and making the big bucks. Good. What does the network admin say when he or she gets home? There's no place like 192.168.1.1, no place like 127.0.0.1 or 10.0.0.1. All right, the answer was there's no place like 127.0.0.1. That's a local loopback you'll learn about this semester. So that's something fun to get us started. Pretty painless, right? And it's totally not worth any score. By the way, this site is called Kahoot.com, is the website that you can sign up your own for your own as a student, or you can even register one as a teacher, and then you can set up your own quizzes and polls and stuff for meetings. So it was developed by educators. targeted at K through 12, but it's starting to saturate colleges everywhere. And they do have some prefabbed ones built in that you can play. You explore different games, different. Go back to that one. Where you're going to find Kahoots. These are actually ones that people have created. And so you literally can just click on them and then just play it online with your phone. So anyway, we'll be doing that each week. Pretty fun, right? Something different. All right, so this is intro week. We're going to cover a little bit on also, we're going to try to cover 1 and 2 content tonight. We'll do chapter 1 as far as discussion. The way the course is made up again, when you come in, you'll log in via the iPad with that website initially to get your QR code. We'll jump right into the discussion for that week and then take a little break sometimes. Sometimes we won't take a break depending on the lab. If it's a short lab, we'll go right into the lab, finish the lab, and we're done. Generally, we're out of here by 9:15, 9:30. Very rarely go to 10. There's a couple labs we go to 10. Our cabling lab, we go to 10. And one other lab this semester will go to 10 as well. And so you'll be out of here by 10 at the latest. And so restrooms, when you leave the room here, take a right, take another right, women's, left, men. All the way in the basement is the pop and water machines you're more than welcome to get when you come to class next week. Just leave a lid on the bottle and you're good to go. So let's go over the makeup of Eagle real quick. 2620 is a room number, 7:30 is the time every Thursday. That is my Google phone number. The 815-617-9759 is the Google number. And you can call or text that, and it will, you call, it'll go right to voicemail. And if you text, it'll go right to my phone. And I will reply as soon as possible. I prefer email, but if you want to text, you can text. I don't mind doing that, so I put it out there. These top links, Periscope will be using a little bit this semester for interviewing folks. It's a video kind of online thing. General course navigation helps. Basically, the course is made up of modules in Eagle, which you've had a chance to look over maybe. Each module represents a page, and each page represents either a discussion, an assignment, a reading assignment, a lab. New module cannot be started until one's completed. And then you complete each module when you have completed that week's module at the end, a little sticker. Main pages are home page. When you first come here, you see a home page with everything on it and the images of each week. Announcements, read those. I try to have the weekly announcements by Monday, posted by Monday of that week. And I just give a little blurb on what we're going over, chapter-wise, lab-wise, or something. Modules shows all the modules, syllabus, all assignments, and grades all your grades. So if you click on the syllabus on the left side, that's probably my most favorite view for students to learn how to use, because you can see all the due dates when they're due. Now, even though we're doing lab 2 next Thursday, so you won't miss this grade, on most labs, I have you just click on the lab and put your name. While we're in this view here and we're in week 2, go ahead and click on 2 lab. And I'm going to go ahead and have you submit your name for the network topology. And all you need to do is hit the submit button on the upper right corner. Your screen looks a little different than mine. The submit assignment button, and then you'll put in your full name and submit that name, your name. That'd be awesome if you could do that. So last week, while you're doing that, getting started and the about me. Before we do that, I'm going to finish on that top tier while you're putting your name in there. I'm going to go over course documents, which is the second line underneath our header there. Course documents is just stuff over the semesters and the years I've taught this course that are available. want to put this Network Plus cert live for you. So getting started is what you did for week 1, which was last week, getting to understand the modules, understand where things are. You read that. Good. Research paper. At the end of the semester, in lieu of a final exam, you'll do a research paper presentation. I do that for my 110 and my 130 class. And it's 5 to 7 pages in length, excluding illustrations and bibliography. 1-inch margin all around, 1.5 at the top, double spacing for everything but quotes, 10 and 12 point font, Times New Roman or Courier, illustrations welcome if good quality, and cover sheet optional. You don't need a cover sheet really because you're going to be emailing it to me or uploading it here at Eagle. I won't read everything about the attribution, citing sources, but definitely do that on your own. And also there's an MLA link to help you if you haven't written a paper in a while. Around mid-semester, I help you on showing you how to create an outline, by how I've done over the years to help you with your research. Because once mid-semester hits, around midterm, spring break, it kind of goes really fast after that. And so, but creating a paper and doing a research paper creates your ability to present. And in IT, regardless of what field you might go into in technology, you're always presenting to somebody something, whether it be individually or by group. You're teaching somebody something all the time. You might not call yourself a teacher, but you will be teaching folks something about what it is they're doing in their line of work, right? And so by developing public speaking skills while you're in school, that's the best time to do it. If you have stage fright, that's the best time to overcome it. In a small group, non-judgmental, and just presenting what you've learned. And you also get to play the part of instructor, which, believe it or not, you might actually enjoy doing. And so when I was in my master's degree, I took over for a professor of mine that was named Dudley Moore that did a fishing lure catalog every semester. And he would travel all over the world, and he'd have all of his students teach for him. And I actually fell in love with teaching, subbing for his Photoshop class and teaching for him. So you never know. 10 to 15 minutes in length is a presentation, which is not real long. When I go over mid-semester, the help with your outline and your presentation, it's about a 12 slide minimum presentation, maximum 15 slides to get 10 minutes out of that. Any more than that, it's going to be over 10 minutes if you try to have more than that. So I'll help you with that. You can use PowerPoint. You can use Prezi, which are the 2 most popular that I recommend. PowerPoint, you've heard of probably. Prezi, maybe not. Prezi.com is an online presentation tool, which I'll show you what it looks like while we're talking about it here. Yeah. I would have my password changed probably. I can't get into this time. I'll show it on my front page here. Let's just do it this way. I might have an account with this and I can show you. You should be able to look at one here. There we go. So I just did a Prezi a couple semesters ago, 2 semesters ago actually, on emojis. Big thing on emojis. And this was a Prezi on welcoming new students to campus. And what if emojis could speak? What would they say? The top 10 emojis. And so I'll show you a little snippet here of what a Prezi can do, which is a little different than PowerPoint. You'll see in a second here. So there's full screen mode. And so you can literally, as I just showed you there, I'll go back out to where it was. The text you'll actually get ready to see is actually down in this area here, but it's so small you can't see it. When I hit the advanced bar, it blows that text up. It's literally microscopic. The text is so small that you can't see it till you zoom in. You play video built in as well. And it's totally free too, by the way, to use Prezi. It doesn't cost anything. There are tons of templates out there you can use. Go full screen here. I won't play all the videos. I'll play a couple more slides just to show you the transitions here, what it can do. Going back out to the normal home view here and coming back in. Watch the emoji. Anybody seen the emoji movie, by the way? It's kind of a DC movie, probably.
You know me, I'm a favorite.
Our grandkids love it, so it's kind of funny. It's cheesy but funny.
He's a knucklehead, literally.
He's a handful.
Candy!
Oh, I'm never eating another piece of candy ever again.
High five, don't do it. Don't you do it. It's already been in there once.
Wow, the Emoji Movie.
Oh, wait a minute.
More slides here. And not again, just you can even use a PowerPoint remote control to control it. So you get the gist here. So again, that is Prezi. And Prezi is, again, pretty easy to create and to use. And it's totally free. What I suggest on Prezi is you can even play with it, you know, when you sign up for a free account. You can come out here and search for Prezi. So say you search for one on, say, you know, set up Wi-Fi. Say that's what you end up doing your presentation on or whatever. Setting up a secure Wi-Fi or something. Let's do Wi-Fi then. Set to the home button. There we go. And for a reason, they've updated the app. You have to go to the next app. I'm going to show you that. But anyway, you can search for presentations in Prezi that you like, and then you can copy those. And there's two versions. The Next is the one I'm using here, which it's a different feel than the Classic. The Classic is the one that I used for years, which has tons of examples to help you. So anyway, prezi.com is the name of it. So just another different presentation tool to play with. So 10 or 15 minutes on presentation. Topics, in the next couple of weeks, you'll be selecting a topic, actually, here in the next week, I believe. These are the topics. If you don't know what these are, which you probably won't, you can Google them and figure out what they are. If you don't like any of these topics, you can choose an elective topic of your choice. All right? And that's found, again, in the modules, and also it's in the home modules called Zero. All the zero ones are the course documents. Course success. Make sure you've done each reading before coming to class each week. The text is PDF download. Doesn't cost you anything to use it. So do the reading beforehand. Participate in class discussion and labs would be great. And complete all assignments by due date. If you're going to be late, just let me know. Or if you're not going to make it because of work or whatever, car problems. And if you can, let me know before class, if not soon after. Silence your cell phones when you come to class. That's fine. You don't have to turn them off. Just silence them. That'd be great. Periscope. I told you about Periscope a little bit. Anybody heard of Periscope before? One person? Okay. Well, Periscope is an app created by Twitter, owned by Twitter, to do video type of interviews. And so here is a couple. I'll show you one example here. It's this one. Open talk. Let's see if we can go to another one. Let's pick one like Doug. Oh, here's Doug Jensen. Here's a RBC president. Well, good afternoon, everyone. My name is Professor Chuck Conkle. This is TechScope Tuesday, the CIS Division weekly Periscope, where we share tech news, highlight RBC faculty, staff. I'll pause it. So anyway, it looks like that. So the person on the right is one I'm interviewing. I'm on the left there. And then we just talk about whatever. I have a little script I sent them. But we get to know the person on campus. And we also interview students at times and business folks from around the community. It's a free app to download on your phone, Android or iOS. And this link will show you how to set it up and describe more about Periscope and TechScope Tuesday, what it's all about. So download that. I'll probably use it a couple times this semester, not a lot, but we'll do it a couple times. And it's good for you to know how to use the technology anyway, since you're in school for learning technology, hopefully, especially if you're in this building. If you're interested in a certification for Network Plus, which is a generic certification, there is a video and website by Professor Mesner on creating CompTIA, getting ready for the CompTIA exam, which is really good resource to help you. And so I suggest to students for CompTIA, we do the testing here on campus, and it's a really good certification. And if you go through the CompTIA study that he goes over and the online free test prep, and you can for sure pass it. I tell students to do it over the summer months, probably be better, so you have more time to do it and be more successful at it. So definitely that's one I recommend is Network Plus. If you have any questions about it once you go through it, let me know. I can definitely help you. Course discussion. If you have questions about the course, non-course related items, this is really for non-course related discussions, is what I developed. Since we only meet one night a week, this helps build community online through course discussion. So you can post, I'm getting ready to buy a phone. You guys have a suggestion? I want to sell my phone. I want to get rid of whatever. Whatever question might be. It can be political nature. It can be news of the day with nature. Just be kind to each other, and you'll be fine. Questions on that? Okay, good. Course discussion. Check. Connection bot assistant. This is a place to connect with me or others. I do speaking around the Rockford region, involved in training teachers and other K through 12 kids in coding and networking. And so a lot of stuff's on here, but also if you wanted to say, okay, what's the upcoming events? It'll pull up a grid of all the upcoming events we have coming up, and from our website that you can actually come up. One of them that everybody probably might be interested in is the resume workshop, February 20th. We also have, as you can see, starting next week, Girls Who Code is a meeting downstairs. Girls 6 through 12 grade are coming to that. That's new this semester. And it's just filled up. And so anyway, you can browse through all the events coming up. And then you can refresh the page to bring back the main page. And if you browse from your phone, it should render for your phone as well. On that. Talked about the Exam Plus already. Textbook download. You can download that to your tablet or phone or computer. Week 1 was a getting started that we already went over. And we went over the research paper. Let's see what else here. Poll. Didn't do that yet. We did the fun poll. This is kind of a fun poll, but let's see if I can open that one up here. We'll do teacher paste. I think I had the same questions there. I don't want to play it because I think we guys already did all this. Yeah, same question. I'm not going to do it again. Okay. That's the same one as we did earlier. I like the fun one better. This one's a little boring. Podcast is what you're watching now. Will be a podcast each week. I put it in week 2. That was week 1. Most of you have put in your about information. Make sure to reply to at least 2 others if you haven't done so already. I think everybody's already done that. Let's see what else there. Week 2, which is tonight. We're going to go over chapter 1 here in a second. That's tonight's podcast there. The lab we will do next week at the first of class. We'll do it. Review questions. Let's talk about that. In the back of every chapter, there's going to be questions in the back of your PDF chapters, and I just need answers only. So like 1A, 2B, 3C. There might be essay questions, being an essay answer as well. 20 points. Upload it when you're finished.
What is essay? I saw that. I don't know.
Do it up.
What's essay?
A short answer. Yep. And so either multiple choice, short answer. Most of them are multiple choice, but there are some short answers in there. All right. Let's see here. Podcast went over that. Quiz. You have up to 3 opportunities to take the quiz. Get the highest score out of 3. And I'll show you a preview here. And again, it's from your reading. It'll tell you where the reading's from. It's chapter 1, Introduction to Networking. If you've not done your reading, it will force you to read, basically. It is open text. So just make sure if you've done your reading, it'll go much faster than if you haven't done your reading. If you haven't done your reading, you'll read a question and go through the book or go online and read it on your phone or whatever. So it's just going to be quicker if you do it reading before. At least skim your reading would be helpful, I'm guessing. Questions on review questions or quiz. All right. And we talked about research paper topic. Now I want to bring up my podcast or my slides for chapter 1. I don't want to do that. And this is just a general introduction here. I'm going to go over. Okay, so in the first poll that we did tonight, a couple of questions was client server, peer-to-peer. We'll talk about some of that on this slide. And some of the certifications available, networking jobs available. But networks, what they are is basically just a group of computers connected together, or devices today, because there's so many bring your own devices to work that people bring, whether it be a tablet, a phone. And so a lot of different devices are brought, connected by multiple types of media. When I mean media, I mean like Wi-Fi, wired, satellite, Bluetooth. And then a standalone computer really doesn't exist much today, but it's really technically a computer by itself, disconnected from everything, even the internet and network, which there isn't too many around. There's some research and development folks or places that have those, but for the most part, everyone's connected. Advantages of networks over standalone would be you're connected to tons of users, whether it be in the workplace or online, and you can share data, you can share information, all from a central resource on a network. Different models of networks are how they're positioned. Like in this classroom, this is a different model of positioning to where it gravitates more towards helping in group activity and group communication versus row type of setup or cubicles. Cubicles, everybody's by themselves working in their little cubicle, which you might have through the day possibly, which is great to get work done, but not really great communication. But it's good to get work done in a small area. Controlling levels over shared resources, like not wanting everybody to have access, or except for HR, to have access to HR folders, to where maybe you can only see folders in your department on the computer network, but you can't see folders in HR department. Things like that you'll learn about this semester. Also, communication and resourcing sharing, to where you can share video, audio, things of that nature, text messaging, and then network models. What these two are in the peer-to-peer is where you have two phones, two laptops, two desktops connected together with whatever medium. That medium could be a Cat5 cable, like in the back of the room there, or like up here at the top of this blue cable that you'll be creating this semester around week 5 or 6. And by the way, that's one of the 10 p.m. nights. This is this one here. But it's a lot of fun. And client server is basically where you're connected like you are tonight, to where you logged into your computer, or you log into your computer at work, and you're connected to each other, but you're also connected to a mainframe computer that authenticates your login and password, username, password, and you can share resources like data, databases, programs, critical data. And the importance of networking, you'll learn this semester as well, is when you're working with critical data, like databases, you want them to be in a resource to where it can be backed up on a daily basis. For God forbid your computer crashes, we can just replace your computer and still have the data in the source on the network where it's going to be safe. Easy to install computers and programs, very difficult to restore data, or near impossible if the data is not ever been backed up on a personal computer. Peer-to-peer is direct communication, as we mentioned earlier, equal authority. So if I'm connected to you with my laptop and you're connected to me, we both have equal authority. I can share resources with you and you can share it with me. I can share folders and files, what you'll learn how to do this semester. There's a lab that you do just learning how to set up a network and share files and folders to one another. You can also prevent people from accessing things on a peer-to-peer. Traditional model is 2 or more computers connected together via a cable. USB is usually the 2 most popular ways. It could also be Wi-Fi as well if you had no internet connected to it, but most of the time there is. Here's a peer-to-peer diagram here, where everybody is kind of on the same playing level field. The problem is if the top right computer doesn't show up, that day and they have the data needed for the group to work on, that's not going to be much work done on that day on that whatever project it was you're working on. Advantages of peer-to-peer is it's simple to set up, least expensive. Disadvantage, not flexible, not necessarily secure, and it's not practical for large organizations or even medium organizations. Peer-to-peer offers ability to share resources easily. The user is responsible for controlling that resource, whether letting people in, letting people out. Not centrally controlled. Environments would be like your home or all small office. Large networks that are peer-to-peer you might have heard of. Gatnella, Freenet, Napster, and BitTorrent. BitTorrent is probably the most popular today. And most companies use BitTorrent to download files. Like Microsoft uses BitTorrent, Apple uses BitTorrent, Dell, HP. So when you go to download a file from those sites, you're using a BitTorrent connection to download. And all that means is that literally thousands of computers or servers have that file you want. And the way BitTorrent works is it can grab that one file if it's in multiple locations, and it can split up that file in thousands of different fragments from those locations and then download it to one file on your location where you're downloading it from. And so that's in essence what BitTorrent does. And it makes it much more efficient for servers because you're not going to download it really fast, and the data is not as large if it was just one file. Now let's flip to client server. Client server is where you basically have a central resource, which is a server or servers plural, that facilitates communication, authentication when you log in the morning, resource sharing, like I mentioned already, a database maybe, multiple documents that your workplace uses for sales or for if you're into manufacturing, it might be AutoCAD. It might be if you're in media, videos, audio, or you're a TV station or a magazine, it might be your different magazine articles that are in there and all the videos needed for possibly if you're into videography or some type of video company. Clients are workstations or personal computers, or today probably tablets is huge in the workplace today, whether it be Apple, whether it be Microsoft Surface Pro is the top two tablets in the workplace today. A year and a half ago, tablets and smartphones surpassed laptops and desktop sales, and it's been going up ever since then. Meaning declining is laptop and desktops, increasing is the sales of tablets and smartphones in the workplace. Because pretty much most of the communication most people do, 6 hours of the day, 5 hours of the day, can be done from a smartphone, whether it be email communication, whether it be discussion via chat, via video chat, whatever. And then most folks like to do document work. They can do it on the phone, but like to do it more on a tablet or some type of laptop. But most are using tablets today. Central resource is also a benefit where it's controlled by the server, meaning if this side over here is marketing, this side over is sales, I can say, okay, marketing, you get to see a drive we'll call the Q drive, and you get to access all of that. This side over here, sales, gets to see the R drive and all the and can access that, but you can't see each other. And so we can do that in networking. Also, too, if one of you leave say one of you left and went to another area, all we would do in a network environment is move you physically in the computer on the server from one group to another group, and then you would have those rights of all that group has by moving you. There's no direct sharing of client resources, or shouldn't be any direct client resource sharing, because it's all centrally located on the servers. So computer roles, you got the server, the clients that run local applications like Word, Excel, PowerPoint, internet type of apps and browser apps. The data, though, that you get, it should be from the servers. That way, again, if your computer crashes, which we know they do sometimes, all we do is replace your computer in the programs, which is not that big a deal. All right. Data, though, is a big deal, and documents is a big deal. And so those are generally all stored on the local network. And also, too, as you probably know, users also have ability to have their own user folder on a network. of say from 5 megs to unlimited size that whatever the workplace gives them. Communication is another role, which is the switches and router. On your tables, we set it up this way on purpose. You'll actually see some switches actually on your table towards the wall on both tables. The ones that you guys are connected to is the very bottom switch, which you'll see the lights blinking. And from your computer, the cable goes into that switch, and that's how these computers communicate one to another. It goes under the floor of the building here, in this floor, and goes directly into the IT lab, the other Cisco IT lab. So switches and routers are important when it comes to communication because, as these mentioned on your table, they can connect up to 24 per device, and then they can daisy chain them together to communicate and add more computers easily. So here's an example of a connectivity device with a switch there in the middle and connected, you'll notice, to a server, a couple workstations, and a printer, all connected via a connectivity device, a switch. Now, switches are a smart device, meaning you can learn here on campus how to program them and to configure a switch to allow for such things as certain websites to go to that you can't go to, certain protocols you can use and can't use. An example of a protocol you'll learn this semester is FTP, you might have heard of before. FTP is a protocol that goes on a port 21. You can block that from a switch level on a switch itself. Or maybe you want to block people from emailing for whatever reason, where you can't send email. You can block port 25 and port 110. Those are used for sending and receiving emails. And so there's just some examples of configurations you can do in a switch. Server requirements. The operating system on a server is different than the operating system on a desktop or laptop computer, whether it be Mac or Windows or Linux or even tablets. The network operating system is designed for a network computer, a network server, all right? And it has in their ability to manage client resources, meaning you and I manage our authentication of our username and passwords. It ensures you're authorized to log in. You can even manage the time frame you can log in. So I can literally, in a network operating system, I can literally say you can only log in from 9 a.m. to 5 p.m. and that's it. It won't let you log in a minute before 9 a.m. and it kicks you out a minute after 5 p.m.'s over. You're done. And you can be that granular in your selection. It can also control file access, which we've already talked about on a peer-to-peer level. You can do the same on a network level in the fact that when you two log in, you're two separate entities, marketing and networking or marketing and sales. When you log in from anywhere in the building, doesn't matter what computer you're on, if you're set up your network operating system right, it will suck down those rules that we've set up for your user account, and you have the same access from any computer and the same limitations from any computer on the network. And what they call that in networking is roaming profiles, to where you basically have a roaming profile. You can just go anywhere you want to within the network and have the same rules apply. Supplying applications to clients. You can push to a client applications from a server. An application like, say, trying to think of a good example, Adobe Suites, okay, Adobe Photoshop, Illustrator, those type can be on a server, and then pushing to the clients a very thin application, very small application client to run, and then it can keep track of the licensing that way as well. So if we buy, let's call in here, we buy 10 licenses for Adobe Illustrator, let's say, and we have it on our network. When the 11th person tries to access that in a network, it'll literally pop up a message and saying, you've exceeded your license, wait until somebody else gets off, because there are 10 concurrent licenses, meaning only 10 people can be on at the same time. So networks help with that, which you can't do on a client-only architecture. Server examples of operating systems are Unix, Linux, Microsoft Server, Mac OS Server. The top three would be Linux, Microsoft, and Mac OS. Those are the top three. In an office environment that usually uses Outlook and Office suites, generally you're looking at Microsoft servers. Designers, companies like Pixar, Back-end servers are more likely going to be Linux and Mac, those back-end servers, just because they're designed for media and they're designed for graphics. Okay, if you look at the history of Pixar, when Steve Jobs bought it and then sold, before he bought it and sold it, their operating system that they had was a unique operating system built on Linux, and it's still to this day a Linux operating system they use to render all their animations, and there are thousands and thousands and millions of frames that they do, all through a Linux that really Microsoft can't do. It's not made for that. The servers aren't made for that. And even Mac can't do that, but Linux can do that because of the nature of it. On the Mac side, any multimedia firm like a graphic design company, a magazine company, newspaper, if you walk through those type of companies, you'll see a lot of Macs in those companies. And again, it's just the nature of the devices, how they're made, and who they target. But server-wise, again, the top three is going to be Linux, Microsoft, and Mac. Unix still around, but they're more old school and called mainframe units, which are found a lot in big hospitals. Like I guarantee OSF has a mainframe Unix. Swedes has a mainframe Unix. And Rockford Memorial, which is now called Mercy Health, has mainframe unit as well, called a Unix mainframe. Server features relative to client. You definitely have more memory. Most of your desktop laptops have average today of 8 to 12 gigs of RAM. It's not uncommon for a server to have hundreds of gigs of RAM. 128 gigs of RAM, 200 gigs of RAM, a terabyte of RAM. Okay, depending upon the makeup of the servers and what it's doing, it can have as much memory as is needed because you can daisy chain those processors together. Storage capacity and processing is another thing that you're not going to have on a client. It's going to be a richer thing on a server just because it's handling more data. Like on, for instance, a processing power in a computer, desktop, laptop, even tablet, quad-core processor, which is a one processing chip. On a server, they can have up to 16 to 18 to 32 processing chips on a server and multiple motherboards on that server, which you'll learn about what that is this semester. Storage capacity, when your hard drive dies on your computer, my computer, we just have to get a new hard drive. We have to unplug it, turn it in, or fix it ourselves. For servers, they have what's called hot swappable hard drives, meaning the servers can be running, right? A drive die, I can take it out of the bay and just plug another one in, and it still doesn't affect it at all because it has what's called RAID technology that allows you to be able to do that. Now, all of that sounds really simple the way I explained it, but it's very complex, but it's also something that's standalone computers can't do, and a big difference between standalone and networks. Disadvantage relative to peer-to-peer, well, complexity, as I mentioned already, and maintenance and money. It's much more expensive to set up a network than just a peer-to-peer. Advantages over peer-to-peer as well. User credentials are stored in one place, so that's a good thing. You're logging into one central location versus your computer only. Multiple shared resources. If your computer dies, that's okay. All the data is on the servers, backed up daily. Central problem solving. I can connect to any of my clients through a server application to remote control of that computer, to help desk, whatever it is I need to help them with. User response time is much better because, again, most networks are set up to where they have like an icon on the desktop that says help, IT help or something, and you can get IT immediately to chat with you and to help you with whatever help you might need. And then efficient processing on large networks. This is referring to like near quantum computing, which is like Google's looking into that, into quantum computing, which we'll talk a little bit about that this semester, what that's about. And also large computing that maybe does cancer research. Computer resources does cancer research on supercomputers is what they're called. Scalability on networks as well. You can keep adding computers. So even though like in this room, we've got only 4 ports per table that we're using, we can definitely add more, no problem. We have 24 ports just on the one switch we're using per table. So 20 plus computers can be added each table. Now we run out of room in here because we don't have the room for it, but capacity to grow is there if we want. Popular in medium and large scale, and even smaller ones today because it's more reasonable to use. So LAN, let's talk about that some more. And that was one of the questions on the poll, local area network. It's actually only been around since the 80s. Started in the 80s. Not been around that long. Became popular with peer-to-peer in small offices in the 80s. And today, much larger in complexity. Next is a MAN, and that's basically a LAN computer connecting to multiple LANs from around a region or location, like here on campus. We have the WTC building, right? The JCSM, CL1, CL2, your student center, PEC, the maintenance building. Underground in the network here is tunnels all over the campus that actually a golf cart can drive through the tunnels to each building I just mentioned. And there's fiber optic cables that run in between each building that connects each building or each LAN. So each building has multiple LANs per floor, and we are now connected on this area. We could say as a small MAN, a metropolitan area network. And it connects multiple buildings just like this location does. A WAN is, we could say, Stenstrom Center. We could say the Bell School Center, the RBC, or our Star location on the second floor downtown. Could be all those locations there that are on the top there, left, right, and bottom can all be connected one to another via a WAN connection. Anytime you hear the word WAN, think of internet. It's internet connected. So here on campus, we have Illinois Century Network is our ISP, our internet service provider. And so we're connected through Illinois to connect us to all of the other networks in our connection. So Illinois Century Network will connect us to Stenstrom Center via Wi-Fi and WAN link. And you'll notice on the routers, each location has its own router. And you'll learn about what those are this semester. All you need to know tonight is a router is a smart device that guards the traffic going in and out of the network. It keeps things safe, basically. So WAN, LAN, and MAN. WAN, again, two or more geographical, as already mentioned. So campus locations is a good example of that. Stenstrom, RBC main campus here, our Star location, the Bell School location. Comparison to LAN, slightly different transmission. We could use satellite. We could use fiber. Could do direct fiber, which we have done in the past. Could use point-to-point satellite, dish technology. So a number of different transmissions could be done. So usually the LAN median or the media transmission usually goes longer distances on the WAN technology. And a different variety too might hit. And the way it works is like between here and Stenstrom, right? And we'll do this semester where we do a ping lab. We actually get to ping certain locations, and you can see exactly what routers it hits along those locations to get there. Okay, so it might hit 5, 6, 10 routers between here and Stenstrom. And each location is going to have a different connection speed and different service provider and a different internet service provider to where it might be fast from point 1 to point B, from this router to router 2 might be really fast. But router 2 to router 3 might be a slower connection because of the provider of that location might be slower. And so that kind of plays into the connectivity. And it's kind of cool to see in that lab, though, on a map where things are at and where they're going. You can literally see the lines of where the data is actually traveling when you try to click on a server or find a server somewhere. Network connection, separate offices in the same organization, like the ones I mentioned here. The different locations we have here on campus and Stenstrom and RBC downtown, or separate offices in different organizations. Like, for instance, I worked for Pepsi for years going through school, and PepsiCo is main mothership is in Tulsa, Oklahoma, but they also have pretty much either a brick and mortar for their trucks to park in at night to load up the bays with pop. Like here in town, they've got a couple of them. And then they've got that big PepsiCo building, I believe, on 90, going towards Beloit on the left. But again, all these locations I just mentioned are all, I guarantee you, centrally located and connected to the Tulsa plant for reporting every night. So when the drivers come back from their trips every day, they have these handhelds. You might have seen them in the stores. They dock them in their trucks. And at the end of the day, all that data is going back to Tulsa. So they know by 5:30, 6 o'clock that night, roughly what their numbers were that day as far as delivery, trucks that were down, locations having issues, all with the network, all doing a couple different network types. You got your handheld network, which is wireless, Bluetooth, and then once they dock it, then it goes from that to the antenna in the truck that hits a satellite. Then from that, from the building where it's in, like here in Rockford, it hits that, say it's from that building on 90. Then from there, maybe it might be hitting a direct, fiber cable to another location. Then from that location, it might be doing over a satellite possibly. You never know what the connection is going to be. It depends on what they can afford and what's available. Now, being PepsiCo, they can pretty much afford whatever they need, I'm guessing. So here's a simple WAN, very simple. You'll notice in this one, it's got two LANs, one on each side, and then the routers on each side as the defense for each end, and then the WAN connection in between, which is the wireless, or not the wireless, but the internet connection. So elements common to client server, you've got basically the network computer requesting information and services from another network computer. So I'm connecting, I'm asking you for, say, we're emailing back and forth. Let's say that. We're emailing back and forth in the same organization. We both have Outlook on our machines. I send you an email. You send one back. We keep volleying back and forth throughout the day. Well, the intermediate device is that exchange server, that email exchange server that's collecting all that data, making sure it's getting to where it needs to go. So you're going to have the exchange server on the server itself, the client workstation, and a person behind that workstation, and some software as well. In this case, Outlook is going to be the software we're talking about. On the server side, it runs a network operating system we already mentioned, which is different than client operating system, like Windows 10, which everybody's using probably, or Windows 7, roughly. Most of you are using those two on the Windows side. And it runs a network operating system, or the term we use in networking is a NOS, N-O-S, is what we refer to as a network operating system. And then workstation uses a personal computer or a tablet, and it may or may not be connected to the network. Most likely it is connected to the network today, though. Okay, let's talk about NIC cards. This is one of the labs we do this semester on NIC installation. And I like this first week, even though last week was technically our first week, we weren't together. This first week, we talked about a lot of technologies that we'll be doing labs each week. And when I built this class 20 years ago, I purposely built into it the lab interface because students only learn so much on slides and discussion. You're only going to learn so much. Once you stop the slides and actually do something hands-on, we'll start next Thursday, you actually get it a little bit better. Now, you might totally 100% get it, but you get it better than just watching something or talking about something, right? At least I do anyway. And so I enjoy watching you guys do it and to learn each week as well. And that reminds me, before I forget, each week when we do the lab, we will have a handout that you'll get or software. So it's a good idea if you want to bring a 3-ring binder with you each Thursday to put in the handouts, because all 3-hole punch them, and then also software that you'll get. So by the end of the semester, you have multiple labs. By the end of the semester, you can replicate at home, and software you can use. And some of the software will be helpful outside the class too, to where you can basically use that lab on a computer to help somebody or help yourself in a workplace or home environment type thing. So bring a 3-ring binder next week if you want to put that in. And it's not a requirement. I'm just recommending it be easier for you to keep all that stuff in there probably. Inside the computer is a NIC card. Okay, now a NIC card can be in a slot on a motherboard, or it can be embedded. Most of the motherboards, most of the NIC cards today are embedded. We'll see some pictures of some in a second. Old school, when I first started computers, networking, it was all slot loaded, meaning on a slot on a motherboard is where you put these NIC cards. And the NIC card basically is the interface to where the network plugs in. Okay, it plugs into the NIC card, and then this goes into the switches, and then the switches go ultimately to the server. Okay, and so the NOS communicates with the server software that communication via the NIC card, getting that information from each computer, being able to manage user groups, security applications, and other network functions. So here's a picture of a slot-loaded NIC card. And the reason I say slot-loaded is you'll notice on the NIC bottom here, there's actually a slot it slides into. You can't see here, but there's actually metal. It's shiny metal there that's underneath it, kind of looks like brass color. That it slides into. And you'll notice this has two other slots available. Slots are also used for video cards, sound cards, scanner cards, just to name a few popular ways slots are used there. Common things available or elements common between client and server is host. So a host enables a network to share, network share by other computers. And so basically you've got your host computer is going to enable network resource sharing. The host computer, another term, is your servers, okay? Or your file servers, you might have heard of that terminology maybe. Or your exchange server I talked about earlier. They help resource people's computers that are connected. A node, I tell students the first night here, the first thing or the first item on a node on a network is a person on the first end or on the very end. All right, then the technology would be nodes like a client, the server, and other devices like your tablets, your phones, things of that nature, to help communicate over the network and identified by what's called a unique number or a network address. And we'll learn about network addresses, what they are this semester, but there's also another unique number called an IP address that you're given as well. An IP address is much like the VIN number of your vehicle within an environment anyway. Meaning it can only, or I take it back, better example would be like your social security number. Social security number should be hopefully unique for every individual person, right? When you go to, well, I won't talk more about that, but anyway, social security numbers should be unique for everybody. If they're not unique, then you're going to have some issues. Same thing on the network, if the IPs were the same, you'd have conflicts and collisions, right? Of information. And so the node on a network, network address, and also the connectivity devices, which we've already talked about a couple, which was the NIC card itself, the switches and routers are all connectivity devices. And they allow for the communication to occur via Cat5 cable, via Wi-Fi, like you guys mostly have set up at home, via Bluetooth. We can communicate via that way as well. We'll talk about this semester. You can communicate via satellite with satellite technology. And then the next common element is segment, a group of nodes. So everything we've talked about hardware-wise, server, computers, desktop, laptops, tablets, phones, whatever, all of those clumped together would be a segment, right? Like this room here would be one segment of the entire network, one segment of the entire building. We could call it quadrant A1 or something would be the segment that we would say. In the next room, quadrant A, B, and then A, C, so on and forth, all the way across. The backbone, that terminology in networking, is what the network drives on, what it falls on, what it communicates on. So a network backbone can be a conglomerate of different things. Like from your computer tonight, you have this connected to it, which is a Cat5 cable, okay? From the Cat5 cable that goes from your computer to the switches on the table, in the back of those switches, there is a fiber on one of these switches that runs into the floor, and that fiber runs all the way down the hall, under the floor, into the Cisco Lab server that authenticates our classroom and gives us resources like internet and being able to share data. Backbone can also be Wi-Fi. That can be backbone as well, like you have at home. Backbone could also be Bluetooth, And those are the most popular I just mentioned. Also USB. And lastly, fiber. Not fiber. The Firewire. Sorry, Firewire is the last one, which isn't real popular anymore, but it's still around. Most of your computers today, by the way, only have ports for Ethernet, USB, Bluetooth. You got that, most of them. And you can even communicate and tether your phone with your computer via Bluetooth to help communicate that as well. Like you can share your computer's internet with your phone via Bluetooth on any computer, whether it be laptop, desktop, laptop, Mac, or PC. And vice versa, you can share your phone's internet with your computer via Bluetooth as well, totally wirelessly. But most people, when they think of Bluetooth, think of what type of usage is Bluetooth used for that you guys think when you think of Bluetooth? Yeah, earbuds, right? Listen to music. Pretty, for the most part, that's what people use it for. But it can be used for other things I just mentioned. Now we'll talk about why it's not used widely this semester. One of them being just the sheer limited length that you can take Bluetooth, but also security concerns as well. It's really easy to hack Bluetooth. And it's, in fact, there's some apps on the Android world called snarfing, and basically where you're basically walking around with an app looking for anybody with Bluetooth connected device to be able to connect to and get data easily from those devices. And so if you have Bluetooth, and I tell people all this all the time, I don't know how many people listen, but most of you probably don't use earbuds all the time, if at all. So really, you could probably turn Bluetooth off. It does save battery, by the way, and it can help you from getting the snarf attack as well, the blue snarf attack as well if you want. And then when you want to use it for your earbuds, you can turn it on. But most people go, yeah, I'll do that, and then never do it. And so, but I'm just telling you that. You can turn it off. It does save a little bit of battery power. And most of you probably don't use Bluetooth, I'm guessing, most of the time. Like, if you're like me anyway, you probably don't use it most of the time. But it's still there anyway. Topology, we're going to do next week. Actually, on Thursday when we come to class, we'll do a topology lab. And basically, I'll put you in the tables you're at, and you'll draw a topology of a network. I'll give you a fictitious company that you can look at, actually, that document I had you sign into tonight in week 2. I'll give you a fictitious company of, I think, 12 computers, a couple servers, a couple printers, and you can draw out your network however you want it to be. And so that's kind of fun. We'll do that next week. But there's 4 topologies in a network: a ring topology, bus, star, or hybrid formation. So when it comes to networks, as far as a backbone, here's a good example of one. We'll say between the client and server and the switches on the left and right is Cat5. And we'll just say, for argument's sake, that the connection between the switches and the router in the middle is fiber. Okay, so you can have a different backbone type. Speed, your fiber will be a little faster, just the sheer nature of fiber, because there's less noise. There's less noise availability. It's less noise susceptible than Cat5. And the way the technology is in creating fiber optic cables, it travels faster because it uses light to travel. So here's the 4 topologies. We'll play with this next week. But on the upper left is a bus topology. This is old school. Okay, how many has cable at home? Cable people? All right. Like Xfinity, I guess what it is, right? Used to be Comcast, now it's Xfinity. Well, everybody has on the back of your TV, though, a coaxial port, right? You plug your cable into. Well, that was a cable we used when I first started networking, was coaxial cable. And the coaxial cable had a special NIC card that a BNC connector that you would plug in that coaxial cable into the NIC card, and that's what you used to communicate. But you also notice, too, on that line there in the middle on the upper left, it actually looked just like that. Basically, you would have couplings that you could keep adding to that line and keep splitting off that line as many as you wanted to. And it was just as fast then, the network was, as our Cat5 is today. But this is much cheaper to make. This is much cheaper to make than coaxial. So the top left was the first type of network, because that was the first only medium we had to play with. The bottom left was the second type, was a ring topology. The ring topology used coaxial, okay? But the way it worked in ring is every computer, for the most part, would have up to 2 NIC cards, one for in, one for out. So 2 NIC cards. And also redundancy was in that one, meaning if I was to send a computer, data to any computer on a ring, so if I was to, this was me, and I'm wanting to send something here, the way it works, if I say I have a 5 meg file I want to send here, the way it works on a ring is, when I go to send it across the network, it copies it to the left and right node of where I'm at. So let's say we'll just go this way. So it's going to be 5 meg, 5 meg, 5 meg. It's going to be this way. Now it drops this one. That's 5 meg, 5 meg, 5 meg. Comes this way, drops this one, this one. Now it's 5 meg, 5 meg, 5 meg. Well, this one finally gets it 100% successfully, that 5 meg file. Then it drops this one and this one. So a lot of redundancy in ring, but installations like banking, New York Stock Exchange, military still uses ring topology because it's a more sure way for data to get there. It's slower and more redundant, but when it comes to what I just mentioned, critical data in banking and New York Stock Exchange military, pretty important to make sure data gets there. Ring topology can work with Cat5 as well. Again, same technique, just different backbone. Top right, forward fasting to early 90s to present day. That is what we have today for most networks that are set up. You'll notice the switch there on the upper right and the Cat5 going to the computers. It's what you have in your tables, basically. So when a new business is setting up a network today, a star is generally what they set it up in, a formation. And so one of those computers, we could say, it's not in that diagram, but could be a server connected to it for authentication, file server. It could be a printer connected to that as well, a router connected to that as well. And if we wanted to add more, we just keep adding more to that switch until we fill up all ports. We want to add more computers in the 24, we just stack it on top of that one, and we keep adding. And in the back of those switches are ports that you can daisy chain each one of the switches one to the other. And so it's fairly simple in that regard to set them up. Now the coding involved is a little complex, but we do have, like I said, Cisco courses on router configurations. Like I definitely recommend you take them while you're here on campus. It's just multiple labs back to back, 8 weeks, and you learn to configure a router and switch. On that makes me note on that point. When you come into class, if you don't have internet connection in here, which sometimes you might not, we do offer Cisco classes in here too, and they're supposed to set their computers back to what's called auto config, which we'll talk about what that is this semester. All you need to know tonight is it's not set to auto config. They didn't set it back, and it's their IP addresses are hard coded in there. Just let me know. I'll show you how to do it the first time, how to set it to auto config, and then you can do it from that point on if that ever happens. Okay, which I guarantee you it'll happen to everybody in here between now and the end of the semester. So when you log in and by the way, that's the login information. Remember, when you log in and you don't have any internet connection, let me know, or let your neighbor know if they already know how to do it. You can ask them first, but if they don't, I'll come over and help both of you, and then you can do it from that point on. So on this slide here talks about the different, again, elements common. One of the elements at the top there is protocol. Protocols are standard methods of communication between networks. A protocol could be, one of them would be like, say, IP protocol, the internet protocol that we're learning about this semester. It's how data flows through an IP packet. TCP protocol, transport control protocol, is the rules around IP. UDP protocol, FTP protocol, talked about that earlier. SMTP for email, POP for SMTs for sending email, POPs for receiving email. Just a few protocols. Data packets. This is where basically distinct units are exchanged between each computer and network, and it's happening all the time. Okay, millions of times a second it's happening. Addressing is basically where you have addressing for every node on the network, both an IP address and a network address. The IP address and the network address both is given by the server to the computer. Okay. Transmission media, we talked about that already, but it's basically Cat5, fiber, satellite, to name the top 3. Here's an example of cabling, what it can look like. Coaxial, you're familiar with from home. So you have cable. The bottom, next one underneath that, we'll be doing in a few weeks, called shielded twisted pair. That's what this one is made up, shielded twisted pair. And it has on the end of it an RJ45 jack, little plastic jack there. It's got 8 wires. And the reason they call it twisted pair is, and we'll talk about more when we do the lab, you want to keep the wires twisted as much as possible, because that's what helps with the noise resistance by the wires being twisted. Because there's really not much there to the wire. You've got the 8 wires and this little bitty skinny blue plastic sheath around it. That's it. So not much noise help there. So the wires being twisted help that. In fact, let me pass it around. If you guys want to look at that real quick, you can pass it around. Underneath that's fiber optic. Fiber optic, again, can be either glass or it can be plastic and light flowing in the middle there. And then below that, radio waves, where it's little point-to-point dishes pointed one to the other for communication. Before we built the nursing building over here, many of you remember that, but there used to be a satellite farm over here. And the satellite farm has been moved to the Mulford location, the Mulford Road. If you keep driving down Mulford till it dead ends, it's right. You'll see it at the end of that. But anyway, we used radio waves years ago, those satellites and radio waves to do point-to-point communication. But that was before high-speed internet. Okay, so we're talking 25, 30 years ago. So when high-speed internet came on board, right, those were used less and less and less and less, just because we really didn't need them anymore, because everybody had broadband connection, everybody, from businesses to home users. But I remember when I first started working here, we had dial-up to connect to the computers on campus. So I would literally dial into the servers. And anybody here remember dial-up? Anybody remember dial-up? Okay, 2 people. 3, 4. Yeah, thank you. 4 people. But maybe when you dial up into a network with a modem, you'd have this really high-pitched screech sound, right? And it'd be sitting there connecting. Then we finally connect. It'll be a whopping 54 megabits per second is what's supposed to be. On average, you get about 12 megabits per second. So what that refers to is this. Okay, just like the slide we're watching here tonight, just to load that slide I loaded earlier, which just took milliseconds from Dropbox to load. Back then, if I was to do that on a dial-up connection, it might take 4 to 5 minutes just to load that initial slide. Okay? That's crazy, right? And then we complain today, though, because things don't happen instead of, that fast, maybe a little bit slower than that. And so, but that's the nature of speed and the nature of technology. So not that too many years ago, though, here on campus, the satellites we did serve a purpose, but we moved because we don't use them as much anymore. But there are some businesses that do use it for certain trainings and things like that. Now, how networks are used as far as, thank you. The function is provided by the network. Most visible use of a network I've already talked about tonight is email. Everybody uses that in the workplace. Other vital network services you use all the time, whether at work or even at home if you have Wi-Fi. Print servers, you might have some of your printers connected to your Wi-Fi at home. Maybe you have an HP printer connected where you can print from any device, right? File sharing set up, internet access, website delivery. You might have your own web host at home possibly. Remote access, you might be able to remote into your computer at home. In fact, I'll mention that right now, a service I would recommend all students on this first week or 2 to load on your computer. It doesn't cost anything. And you can load it on your computer at home. That way, if you forget a paper or something for a class, teamviewer.com, you can log into it, set it up a free account, and download it to your computer at home, Mac or PC. And once you set it up, you can then set it up as an unattended user, meaning once it's set up, you can access it from any device, from anywhere, via web browser. And so you can be on your laptop or your tablet and connect to it, on your phone and connect to it. And they have clients, by the way, for all these devices. So they have a phone client, a tablet client for TeamViewer, and you can help your friends and family out with TeamViewer as well. It's a one-time connection when you help people, that it gives you a one-time username and password. But it's totally free to use for non-commercial use. And you can connect to as many computers as you want to individually from any location with TeamViewer once you download it. So look into that and play with that and get it on your computer. That way it can help you maybe, well, like I said, when you forget a paper, if you want to work on something from home that you don't have an app on your phone or tablet to work on here at school, you can remote into your home computer and work on it there. So I recommend that the first week while you're getting things acclimated, first couple weeks here. Also, the other thing we use all the time we don't think about that's networking is your telephone. I mean, our phones, our Cisco phone here is voice over IP. And so literally on campus, when you dial in, you're dialing in the old analog POTS line is what it's called. It's the old analog lines, right? But then it's converted to digital. And with that digital line, we can do a lot of things. We can shoot video through it. We can do audio through it and voice, all three if we want to, right? And so most of your home users today through Xfinity, which we talked about earlier, can get a voice over IP phone with them fairly reasonable, I believe. Video service is another thing that goes over network. So you can have a video file or video server on your network that can be streamed from anywhere. University of Wisconsin-Madison has probably the largest video servers in the world. They have something like 825 Mac servers that they use to do all of their online streaming on every campus computer. They have their own TV station, they have their own news station, multimedia station, and they shoot it all over campus and around the city as well with this humongous server room they have with Mac servers. And so video services is one, and also network management's the other, where basically tools like TeamViewer can be used to where you can remote into servers remotely from around the world from one location, wherever you're at. So you can literally be mobile, and I can use TeamViewer to log into any of my servers in any location where I work on servers and help people out, and never have to go to that place to do it. Just log in and do whatever I need to do to help them to fix whatever it is I need help fix, basically. TeamViewer also has a new piece in it too, by the way. They just set up a new thing called Meeting. And I'm going to try this semester where you can actually set up meetings, kind of like, WebEx. You might have heard of that. So it's kind of their version of WebEx on TeamViewer, where you can set up a free online session, both video, text, chat, sharing files, presentations, everything. So we'll probably try that out this semester. But TeamViewer is one. We do a couple weeks on what's called remote connectivity apps. TeamViewer is one of them. VNC is another one that you guys will get a chance to play with. On the TeamViewer lab, you guys are going to take that home on that week, and you get to remote into each other's computer and do some things on each other's computer to see how that works, basically, and then give feedback on it, on how you liked it or didn't like it. The other services that are available on network you don't think about, but it's available for all of us, is file services, like just getting files on our server. Disk storage space where we can store stuff. Print services is another one where you can print anywhere from anywhere in a building or anywhere in the world. In fact, if you set things up right, even with TeamViewer, you can set it up to where you're on a computer in here, remote it into your home computer, and print stuff from here to your home computer if you wanted to. Access services, basically you can allow remote access to your computers outside the network. TeamViewer would be one of those. And also providing LAN connectivity with WAN connection is not very cost effective. So a lot of times people today will do remote connectivity. My son works that way. He works at home and remotes into Rockford every day and travels all over working that way. So that's pretty popular today for companies to do that. So you don't have to buy a cubicle for you. You do. Usually it's been proven in studies you actually get more work done, and you have to really watch it. You can actually work yourself to death at home, more so than not. And so they get a lot of work productivity out of you a lot of times from home. And a lot of, I just read a study, I think it was 2 weeks ago, that said that for the first time in some locations and regions in the U.S., that external working, people working from home, has surpassed some regions as far as in some technologies for the first time, basically. So people are traveling, working from home either part of the week or all the week, And so, again, we couldn't do this 10 years ago, but now we can because of technologies like TeamViewer and things of that nature to where you can do that. So when you're logged into that computer and you're in Florida and you're logging into Rockford, you're logging into that computer in Rockford just like you're sitting right in front of it. Okay, it's literally you're doing everything just like you're sitting right in front of it. The other services available is convergence, which is basically the phenomenon of offering multiple types of communication on the same network. So offering video, audio, both on a network, unified communication, multiple different storage management. Like an example would be they have a whole bunch of devices out now to where you can store things through a device called Nimble, to where you can store terabytes of data and mirror what you have on a cloud locally. Because a lot of times companies have been leery of storing things online just because, well, what if it goes down? Okay, I have no control over that. Well, now they have compliant appliances now that actually will mirror everything you have online locally. That way, if it does fail online, you have a backup on your local unit. Email, the oldest and most frequently used. In fact, there's an email client. These are the night I've mentioned a lot of the little apps I recommend. If you have a smartphone, which most of you do, there's a secure email that we use in my 130 class. I recommend in this one called Proton email. It was created by a whole bunch of scientists. And it's encrypted email, and it's no cost to download and to start using. Proton, Proton is the name of it. So that might be one to. It's called, actually the app is called Proton Mail. Proton Mail, all one word, and it's a really good encryption app for email. We will do an encrypted lab this semester with the Proton Mail is the name of it. It was CERN scientists that created this. Yeah, there's a I'll show them later on the semester, but there's a TED video of the CERN scientists that basically like the smartest guys in the world, gals in the world that just think of cool stuff to do, technology wise. Anyway, they thought of this idea of encrypted email, and for privacy's sake, for people to email more securely. Because you maybe not know this, but like Google, Gmail, Yahoo, they don't have somebody actually read your email, but your data is being filtered to where it can push ads basically to your email client of what you communicate in your email. Okay, they catch words and things of that nature. So if you're a sports guy or gal and you're always typing in stuff about different teams you like or whatever, you might wonder why you're always getting pop-up or ads and then that in your email feed of that type of thing that you're emailing about. It's because they're, again, not a person's reading it, but there's an algorithm reading it if advertisers are paying to target you as a person, as a buyer. But you're getting the email for free, but still, and it is they've made it known they're doing this for a while, but I still think a lot of people don't realize that. And so it's nothing to some people maybe. But so Proton Mail helps from that to not happen, to where especially if you have a company, you don't want anybody reading your private emails for company purposes or even for personal purposes. I had one guy did a TED video said, yeah, it's not going to matter most of the communication I have with my wife and my kids about, pick up milk and bread, but, still, it's my wife and kids. I'm talking to them. I really don't like everything. It's no different than somebody coming into your house and just watching you talk to you, you don't like that. So it's the same concept. So anyway, that's how Proton Mail was made. Also, spam's a big one. It's huge still today. 97% of email that comes into corporate email and even personal email is spam. Okay. If you look at your spam box on Gmail, it's totally full, right? All the time. And it purges every 30 days or whatever, but spam market's still huge. It does handle objectionable content through the mail servers with spam filters. But mail's an important part that we'll talk about this semester. And internet services like web pages, internet services like offering desktop support, security filters, and then lastly, management services like being able to log in to a computer and manage from any computer. I can manage my network from my phone, my tablet. You'll learn about all that this semester. So that's a synopsis of networking in general 101, an introduction there. And so next week when you come to class, we forward fast here. Let's talk about due date stuff here first. Lab 2, I had you submit your name, right? Chapter 2 review questions, again, answers only. Do it offline though on the review questions. Like even if you type the answers in your phone in a note document or something, don't do it on Eagle because it does time out after such a time. And when it times out, they say in Eagle it saves your session, but I have had it not save my session before. And so it's best to do the review questions offline, right? And then when you're ready to upload them, just paste them in there and you're done. And the same with the quiz. At least skim through the book. I would recommend before you take the quiz. At least you know kind of where it's at. And then your research paper topic, we do have that due Sunday. And again, read through the topics that we looked at earlier. I think it's actually in the bottom of that document we went over. So all the way at the bottom. And again, you can Google some of these to figure out what they are and figure out if you want to do it or not. If it has anything to do with networking, I will take that. Now, if we forward fast to the last, I think it's the last module. I think I might have left in there some presentations from last time. Let me see here if I did or not. Yeah, on week 14, there's some links of presentations students did last semester in here that you can look at. Some videos, some just PowerPoints or whatever. And so it looks like 14, I kept them in there. So you can look at week 14 of what people have done. An example students have done in the past just recently is biometrics and networking, you know, the fingerprint, iris technology of doing authentication through that. How to secure your Wi-Fi. Networking as it pertains to social media. How does that apply? Is there security ramifications there? Is there things you should be aware of? Is there things that companies can take advantage of they're not taking advantage of? So stuff like that all has to do with networking. So anything that's as creative as you want it to be or as boring as you want it to be, but pick something that you really want to research, that you're kind of interested in, and hopefully you don't know a lot about, but you're just kind of, you read it online somewhere when you're doing your research this week, and you're like, oh yeah, I'd like to do that. That'd be cool. All right. And if you have any questions about a topic, I know it's Thursday and this is due Sunday at midnight. If you have any questions about a topic, shoot me an email quickly or text message me. And my text message number's on the homepage of the site, and I will reply ASAP. It'll come right to my phone. If you've had me before, try to be pretty good about replying to your emails. All right. Any other questions here? All right. So do me a favor before you leave. If you could shut your computer down in front of you, make sure you log off of Eagle and everything. And if you're sitting next to a computer, doesn't have everybody sitting at it, I think I turned every computer on in here. If you could reach over and shut that one down too, that would be awesome. I appreciate it. And if you have any other questions, come see me. Otherwise, let's have a great semester.
What's this, you're supposed to check in somehow?
What now?
I didn't really get how you're supposed to check in.
Oh yeah, come on in. I'll help you. If you didn't get to check in, come on up here and I can help you. All right.